this video, let's talk about what exponential graphs look like. Now, as you know, I have some pretty weird names for all the graph shapes to help me remember what they look like dead worm from chapter 2. The exponential graph, I like to call it the hockey stick graph because that's the kind of shape it looks like to me. Now, you do need to memorize what this graph looks like. Think of it as just another parent function that you need to know. And this graph has 3 key points on it that you need to memorize and know where they are. The first one is that there is an asymptote on the x-axis. So this is a horizontal asymptote at, now, is this asymptote x equals 0 or y equals 0? We know that this asymptote is y equals 0 because it crosses the y-axis. If it crosses the x-axis, that's x equals 0. So this is a horizontal asymptote at y equals 0. Second really important thing for an exponential graph is this point, the y-intercept that every single exponential graph will have in common. And that point is 0, 1. And the reason they all have this in common is anything to the 0 power is 1. Then there is one more point that every exponential graph has in common, and it is 1, the base. And that is because anything to the first power is itself. So those are the 3 points that you need to memorize and have and know that these belong to exponential graphs. Let's show you an example. In this example, let's graph 2 to the x first. We're going to ignore the rest of it and just graph 2 to the x. Well, I know they all have a horizontal asymptote here. I know they all have a y-intercept there. And then I know they all have 1, the base. In this case, the base is 2 to the x. So 1, 2. And that is my graph of 2 to the x. Now let's transform it. So this graph has a +1 on the inside and a -3 on the outside. This is to see if you remember your inside-outside transformation rules. Remember, inside moves side to side and is opposite. Outside moves up and down and is the same. So a +1 on the inside is going to move left 1, where a -3 on the outside is going to move down 3. So I'm going to come back to my graph and move everything left 1, down 3. Let's start with my asymptote. This asymptote, because it's a forever line, moving it left 1 doesn't really make sense. Doesn't change anything. But I can move that line down 3, and that changes it significantly. Now let's do my green point. Left 1, down 3, and left 1, down 3. Connect them with my hockey stick. And there's 2 to the x + 1 minus 3. So that is the graph that has been transformed left 1, down 3. Now we do want to state the domain, the range, and the asymptotes of this graph. And when I say this graph, I mean the transformed graph, not the original. So if I look at the transformed graph, I remember that domain is side to side. So it looks like this graph is going to go forever to the left, and even though it mostly goes up, it will go forever to the right. It's just going to go to the right slowly. So my domain is -infinity to infinity. Range is my y values up and down. So if I look at this graph, the y values that are included are going to be from -3 up. So we write that as -3 up to infinity, and I do not want to include -3 because that's where my asymptote is. Last one, the equation for the asymptote is going to be y equals, because it crosses the y-axis, so y equals -3. And that's how we graph it and write the domain, range, and the asymptotes. So that is a little bit more on graphing exponential functions. In the next video, we'll talk about the last property of exponentials, which is the one-to-one property.